All right, we can start. We'll see. Sometimes people join late. So usually I just kind of give you a little bit of time to solve a problem and then we'll go over it. So let's start with number one. Yeah, okay. So basically for this one, the first thing I would do is like distribute the A. So you get AX plus AB. And what we need to have for no solutions is we need the coefficient of X to be the same, or that's really the slope. And we need the constant or the y-intercept to be different. So therefore, A has to be 7. We got no choice for that. And then if A is 7, we need these to be different. So 4 cannot equal 7b, and therefore 4/7 cannot be b. So therefore it is D. Very good. All right, let's keep going. Let's try number two. Okay, so for this one, it's the last one had to do with types of solutions to linear functions. This is types of solutions to linear system. So in order for there to be no solution, this one is pretty close to standard form. So I'm going to get it in standard form. And then what I want is I want the X's and Y's, the coefficients of all the X's and Y's to be the same. This one's kind of a little bit annoying with fractions, but we'll deal with it. So the first one, if I get it in standard form, it's 2/3 X. And if I add 3/5 Y to this, I get plus 2/5 Y equals 1/2. And on this one, I get 1/3 X. I subtract QY, and then I bring the 4 over here. And 7/3 minus 4 is negative 5/3. So first thing is I just get it in standard form. And then what I want is I want to make um, the X's. I can't make the Y's the same because I don't know what Q is yet, but I can make the X's the same by just multiplying this by 2. So this new second equation is 2/3 X minus 2QY equals negative 10/3. And so now if I look at this equation and this equation, what I need is the X's to be the same, which they are. I just made that happen. And I need the Y's to be the same as well. So I need 2/5, the coefficient of Y here, to equal the coefficient of Y here, which is negative 2Q. And then I just solve this by dividing each side by negative 2. And if you do 2/5 divided by negative 2, you'll end up getting negative 1/5. So if we make the value of Q negative 1/5, we will get no solution. And also the constant on the right has to be different, but it just works out that way because whoever made this problem had to make that work out that way. If it were an infinite solution problem, those would have been the same. So the final answer is negative 1/5. All right, if we don't have any questions, then we will move on to the next one. All right, try that. Okay, so I am going to do this entire problem in Desmos. But before we jump over to Desmos, I'm going to just explain something here that'll be helpful. So we're going to use a Desmos table. So to use a table to create a line in Desmos, we only need 2 values or 2 points. So I'm just going to focus on the first 2. And what happens is this is line H, and line K translates it down 5 units. So when I use the table, I'm going to use 125 here and 155 here. Obviously, this one will go down as well, but I only need 2 points. And then I'm just going to find the x-intercept. So we're going to hop over to Desmos. Oops. And you're going to add a table. We're going to put 18. Again, we're going to put 125 because we're doing the one that's been translated down 5. And then 23, 155. And then you hit this button, add the regression. Linear is the like the default, so that's good. That's what we want. You change it to quadratic or exponential if you were using that. And then we're looking for the x-intercept, which is negative 2.83 repeating. So the downside of doing it, Desmos, is you get that decimal. But we're going to go back to the answers. We're going to figure it out. So we get negative 2.83 repeating. So I go back. And of the answers, negative 2.83 repeating is D. You could check quickly on a calculator, but 6 goes into 17, like 2 times almost 3. So you can do it. You can check the other ones. However, you got to get there. That's kind of up to you. All right. So the answer ends up being D. Okay. Any questions? Okay. All right. Then let's take a look at number 4. Okay. I'm going to show you 2 ways to do this. So first way is I'm going to use Desmos. So let's jump over there. And given that the SAT is coming up this week, I kind of wanted to review some like big things. So one of them is how to use regression to solve problems like this. So I'm going to put in that expression, which is 4x, but every x I'm going to make x1. So I'm just going to type x1 instead of x. And then I get plus 4x1, and then minus 1, and then it was x1 squared minus 3x1, and then use the little tilde instead of equals, and that is equal to ax1 to the 4th plus bx1 to the 3rd plus cx1 squared, and then finally plus dx1. Then what we're going to do is we're going to make x1 equal to a bunch of numbers. And we're going to make x1 equal to 4 different numbers because we have a, b, c, and d as our constant. So I'm just going to do 1, 2, 3, 4. And then I'm done. And then what I can do, the question asks for b plus c. So I can just hit b plus c. And it tells me that the answer is negative 21. So this is called regression, and it's a way to solve these equivalent expression problems that have constants in them. It may or may not be the best way. I'm going to show you another way to do the problem, but it works, as you can see, and I just wanted to review again exactly how to use it ahead of the SAT coming up. So first of all, does anybody have questions on that? Okay. So then I'm going to go back and just show you another way. So the downside of that is just all the typing. But if we're going to do it the other way, then I want to take a shortcut. So I don't want to have to multiply all of these out. So what I'm going to do is I'm going to focus on just b first. B is going to be the coefficient of x cubed. So again, instead of multiplying all this out, I'm just going to pick out the 2 like terms that when I multiply them are going to give me cubes. So that's going to be this one times this one, and then this one times this one. So remember when we multiply these out, we kind of like multiply every combination. I just want to focus on the ones that give me x cubed. So 4x squared times negative 3x is negative 12x cubed. And then 4x times x squared is positive 4x cubed. And when I add them together, I get negative 8x cubed, which tells me that b must equal negative 8. And then I do something similar for c. So c is cx squared. So I just focus on the terms that when I multiply them, I would get x squared. So that would be the 4x times the negative 3 and the negative 1 times the x squared. So 4x, I said negative 3, but I meant negative 3x. So 4x times negative 3x is negative 12x squared. And negative 1 times x squared is negative 1x squared. And that gives me negative 13x squared. So therefore, c is negative 13. And when I add them together, I get negative 21. So again, instead of multiplying it all out and getting terms that we don't need, this just does the terms that we need. If that's confusing, then just use the regression on Desmos. Or maybe that's faster for you anyway. Just wanted to kind of show like a second way to do this. Okay. Any questions? All right, let's try number 5. All right, this is one where you could use regression, but I'm not going to because I think there's a quicker way than typing all this in. And that is if we just try to simplify this by factoring, the numerator factors to x minus 9 times x plus 1. Whoops. And the x minus signs cancel. So you're just left with x plus 1 equals px plus q. So therefore, you could think of this as 1x plus 1. So therefore, this one must be p, and this one must be q. And when you add p and q together, you're just going to get 2. So for me, that one's a lot easier just to do kind of by hand and then save like harder ones for Desmos regression. But if you're not great at factoring and you don't want to worry about that, Desmos regression would work. You would just do it the same way as the last one. Make all the x's x1s and make the equals a tilde, and it'll give you plug in 2 values for x1, and you'll get p and q. Okay, let's keep going. So number 6. Okay, this is a pretty challenging problem. It's hard to use Desmos because it's not asking for the values of a plus b. It's saying like what could they be. So given that there's multiple values and multiple answers, but only one of these would work, I don't know if Desmos would work out too well here. So the way that this one is going to work is we have to know different forms of quadratics. So this is standard form. And then if they are giving us the x-intercepts, we should also know intercept form. So intercept form looks like this. It's a, the same a that's here, and then it's multiplied by its factors. So if -5 is an x-intercept, then that means x plus 5 would have to be a factor. And if 9 is an x-intercept, then that means x minus 9 is a factor. Right? So that's just, again, because if we set these equal to 0, we would get -5 and 9 as our answers. So we're just kind of working backwards between zeros or x-intercepts and then corresponding factors. Then what I'm doing is just multiply this out to get it in this form. So if you FOIL this, you're going to get x squared plus 5x minus 9x minus 45. And then you're going to get x squared minus 4x minus 45. And finally, you're going to get ax squared minus 4ax minus 45a. So now I have it in standard form. And it wants the value, it asks us something about the value of a plus b. So a is a. Okay, so this is a. And b is the coefficient of x. Well, that in this case is -4a. So if I do a plus b, that's a plus -4a, which is -3a. Right. So right now where we're at is the value of a plus b is -3a. Finally, a has to be an integer. So the only answer that could make sense is C, because if a is say 3, -3 times 3 is -9. To get -4, -7, and -10, -3 doesn't go into them. So a would have to be not an integer in order for that to happen. So again, it's a really hard problem. But we need to start with intercept form, get it in the standard form, do a plus b, and then see what this extra rule that they're giving us, and see that this is the only answer here that we could get from this expression, given that a has to be an integer. Okay, questions?
I'm like a little lost, like how you turn the what's it called? The points into intercept
Mhm.
or Yeah, and then also I'm confused on how you got like 9 with like the integer greater than 1.
Okay, so basically, intercept form is what's another name for it is factored form. So it's the thing that gives us the x-intercepts in a quadratic or really any polynomial is when we get it completely factored. So I just want to show you like another example. So like imagine you had, let me see if I can make one up like this, 5x squared plus 10x minus 75. Hopefully that works. Okay. So imagine we had this as our like equation. This is in standard form. If we wanted to get this in intercept form, what we would do is we would factor it. So we would factor the 5 out first. And then we would factor further. And this would factor to x plus 5, x minus 3. And then what would happen is we would set each of these equal to 0 to get that the intercepts are x equals -5 and x equals +3. So that's how we take something from standard form into what's called intercept or factored form. And we would do that if we wanted to find the intercepts or what are called the zeros. So what we did in this problem is, so you just need to know that when something looks like this, it's in intercept form. And when something looks like this, it's in standard form. So what
So
I,
like
go ahead.
oh, sorry. So for the equation, the points that were given, do we do we wait, um oh okay. So you just flipped the sign to like to the opposite sign?
Mm-hmm. Yeah, it's
Okay.
always x minus the 0 is where what the factor is.
Okay, so integer um is basically just like a factorized version.
Yeah. Okay. Well, there's two separate. Are you asking about this part right now?
Yeah.
Okay. So that has nothing to do with this integer part. So
Okay.
we'll get to that in a second. This is
Okay.
just the way you get it something in factored form is you do x minus whatever the 0 is, and x minus -5 is x plus 5, and x minus 9 is x minus 9, and then there's just this value of a that is always in front.
Okay.
Okay, so that's how you, if you're given the intercepts, you want to start in what's called intercept form. And then we just do a bunch of, simplifying to get it now into standard form. And then a plus b is -3a. So does that part make sense?
Yeah.
Okay. So now the way we end the problem is it says which of these answers could be the value of a plus b, which we now know is -3a, if a is an integer. Well, an integer is just basically an integer greater than 1 is just like a whole number. So there's no way we could get -4, -7, or -10 because if to get them, a would have to be some like decimal.
Oh, I got it now. Okay, thank you.
Mm-hmm. So only C makes sense. That's a super hard problem, but again, just we need ways to get started, and the way to get started in this problem is if they give you the intercepts, you want to start with intercept form. So, and I can't really think of a good way to use Desmos in there to help us do a shortcut because again, A doesn't have to be 3. A could be a infinite number of values. It's just that A being 3 will give us the only answer out of these 4 that makes sense. Um, so I really think Desmos will be. I don't see how we could use it there. So there is ways for them to ask problems that kind of force us to know these concepts. So we should know standard form, and then this is called intercept form of a quadratic. All right, number 7. Move on to functions. This is a pretty tricky one, but the amount of work to do is not very much, but it's kind of a hard problem to know what to do. Okay. So to kind of explain this, I'm going to go over an easier example. Let's say we had f of x was equal to, I don't know, 3x plus 8. If we were to find, let's say, f of 2, then we would just replace each x with 2. We would just do 3 times 2 plus 8, which we can easily find, but that's not the point. So basically, whatever is in place of x is what goes in place of x in the function. Now, this one's a little bit strange because, so basically, it's the same idea that whatever we plug in for this x is going to go in place of this x. But the thing that we plug in for x has to end up meaning that what's inside here is -1. So that's the part that's tricky. We can't plug in -1 because that wouldn't result in f of -1. So what we have to do is I'm going to go over here to the side and I'm going to solve this equation. You could maybe figure this out in your head, but I just want to actually show this. So I want to figure out what value of x will make it so that when I plug it in, I end up getting -1. So I get x minus 5. I can multiply the 3 over. And then if I add 5 to both sides, I get x equals 2. So the value of x equals 2 is what we're going to use. And I'll show you again why this works. So if I replace x with 2, I also, whatever I plug in for x is what goes into the function. And look what happens when we do this. 2 minus 5 is -3, and -3 divided by 3 is -1. That is what we wanted. We wanted it to say f of -1 in here. And then on this side, just 2 squared is 4 plus 1 is 5. So the answer to the problem is 5. But the thing is, in an easy function problem, if you want f of 2, you just make x 2. But here, if we want f of -1, we don't make x -1. We have to figure out what to make x so that this expression becomes -1. So it's a much harder version of a function problem. Okay, questions on that?
Could you use regression for this question or no?
Not that I know of. That doesn't mean that you couldn't use Desmos to do it. Basically, just like type it in as is and use x1s instead.
Yeah.
I don't believe that would work because I don't think it'll do functions. And then there's no other like constants in the problem.
Oh wait, is regression just for like constant questions?
Yeah, well, that type of regression. Yeah.
Okay.
Yeah. Making the tables is also like a type of regression, but I don't think that'll work either. So I'm not saying that there's no way to use Desmos to do this, but I'm not familiar with how we could use Desmos to do this.
Okay.
But does it make sense like why we
Yeah.
chose two? Okay.
Yeah. This
Well,
one's like simpler.
okay. Let's try the next one. Whoops. All right. So for this one, I'm going to use what's called a like an exponential model, which is typically AB to the X. And A is the initial value. And B is the decimal version of whatever, whoops, our percent increase or decreases. And I'll explain that more in a second. So our initial value is clearly 74,000. So our exponential model looks like this: 74,000, some decimal, or sorry, decimal version of like a percent increase or decrease raised to the x. And that x is going to be 2. So what I really want to go over in this problem is how to get this number here. So this represents, that's the number that we use that represents something that decreases by 66%. We've definitely done this before when it comes to percent increase and decrease. And to just recap that, if you do nothing to something, you're keeping 100% of it. And if we're decreasing it by 66%, then that means we're keeping 34% of it. So every time we lose 66%, we're keeping 34% of it. So the decimal that's going to go in here is 0.34. So when you have a 66% decrease, the decimal that represents that is 0.34. And then this 2 tells us we're doing it to the second power, and the 74,000 is where we start. So then we're just putting this into the calculator. So I'm going to give you what the calculator gave me and then what we would give in the SAT answer. So the calculator gives me 8,554.4, but you are only allowed to use 5 spaces. So we have to just use 5 characters, 4, because the decimal would count. So to put this number in, we would need to use 6 characters. So we just put in this. So it's forcing us to round, and that 4 means we round down. So the answer to the problem is 8,554.
Wait, so just to be clear, the decimal counts like as a character?
Yes.
Oh, okay.
Yeah, a decimal or like a fraction. So if the answer was like 17 thirds, this would be 4 characters. The only exception to that is a negative. So if you had a question where the answer was negative, the negative doesn't count. You would have a negative and then you would still use 5 other characters. But it shouldn't be an issue because I believe that you just run out of, like, it only allows you to type 5 as far as I know. I mean, I never took this version of the SAT, but like I think what students have told me is that like you wouldn't even be able to like get to this part because you would just run out, like you wouldn't be able to type anymore. But I could be wrong about that. Either way, I'm positive that they only allow for 5 characters. So in a problem like this, and the decimal definitely counts as a character. Okay, let's keep going. So let's take a look at number 9. So we got a unit conversion problem. Okay, so for this one, I'm going to use, I like to use dimensional analysis for these. So I have 5.28 square miles. So I'm going to write it like this. And I'm going to use a version of this conversion factor. I'm going to put it here. And what I need is for square miles to cancel. So I need square miles on the bottom. But again, this is just 1 mile equals 1,760 yards. What we have to do is square that conversion factor. Well, 1 squared is 1. Then I get square miles. I need to square 1,760. I'm not going to actually do that yet. I'm just going to write it as that squared. And then I get yards squared. So again, we can't use this conversion factor as is because it's just about 1 mile, but we're talking about square miles. So now I know 1 square mile is whatever 1,760 squared is. It's that many square yards. Square miles cancel. And then the way I get my final answer is I multiply these. But I don't just do 5.28 times 1,760. I do 5.28 times 1,760 squared, and we get this number, 16,355,328. And if you only do 5.28 times 1760, that answer is there as well. I believe that's C. So just be careful on the ones where it's either square units or cubic units. You've got to like change the conversion factor that's given. All right. Any questions on that one?
So like if it asks for like if there's a good way to ask for like cubic, you would just cube the um the smaller number or like the smaller unit so that it would equal the big unit.
Yeah,
Like,
it's
does
not
that make
necessarily smaller. Yeah, like here,
Yeah.
I'll show you. Like, let's say they gave you that something, the volume of something was like 4, we'll say cubic feet, right? And we know that 1 foot is equal to 12 inches. So if we want to turn this into cubic inches, we need to figure out what 1 cubic foot is so that they cancel. So what we would do is we would cube this. So then we get 1 cubed is 1. We get cubic feet. 12 cubed, I'll actually do that. 12 cubed is 1,728. So if I do 12 cubed, I get this. So that means that there is this many cubic inches in 1 cubic foot, and then that's what would go up here. So these would cancel. My final answer would just be whatever 4 times 1,728 is.
Okay, that makes sense. Thank you.
Yep, you're welcome. Okay, so let's take a look at number 10. I think this will probably be our last one. So try this. Okay, so for this problem, this is where we really need to be able to use the percent increase decrease and come up with those decimals. So let's kind of go through each of these. If the bookstore discounted all the books by 30%, they discounted them by 30%. So if you discount something by 30%, that means you started with 100% and you take away 30%. That means you're keeping 70%. So as a decimal, that's 0.7. So doing 0.7 or 0.70 is how you do a 30% discount. So then the library card allows a 5% discount over the discounted price. So we're taking another 5% off. So again, we're first doing this. So again, same idea. If we start at 100%, we take away 5%. We end up with 95%. So that means we're going to multiply by 0.95. So multiplying by 0.7 is the 30% discount. Multiplying by 0.95 is the 5%, the next 5% discount after the 30% discount. And that is what we would multiply the original price by. We would start our original price and we would multiply by both of these. And in the end, our discounted price after the both discounts is 532. All right, so that's our setup. 30% discount, 5% discount, our original price. In the end, we pay this. So what we're going to do is we could just figure this out. You can probably do it all in the calculator, but if I do 0.7 times 0.95, whoops, I get 0.665x is 532, and then I'll just divide. So 5.32 divided by 0.665 is 8. So our original price would have been $8. Okay, questions on that?
No.
Okay, good. All right, then that's all. I got to wrap it up a couple minutes early tonight. So that's all we're going to do tonight. So thanks again for coming, and I will see you on Thursday, right, at our normal session.
Yeah.
Okay, sounds good.